So in this video, I'm going to be looking at memory and LangChain. So using memory in LangChain. If you want to jump ahead to the code, I've put timestamp here and we'll show on the screen where you can actually just jump straight into the code. So just quickly, I thought we'd look at why is memory important, building chat agents and stuff like that. One of the big reasons is that people treat any sort of chat bot or chat agent as basically like a human. They kind of expect that it's going to have the qualities of a human and respond, and they get very frustrated. They don't realize that often these things are just doing one call and responding to that. So you often find that things that people do is they want to abbreviate when they refer back to things that were spoken about earlier on in the conversation. This can be talking about places, times, a whole bunch of different things. And another big thing that you need to factor in is the idea of co-reference resolution across the actual conversation. So if someone starts talking about a person and they actually give a name, often they will later on just refer to that person as he or she. And for the large language model to be able to pick up who that is, we need to give it some kind of memory so that it can go back and work out, okay, who is this person that they're talking about, or what is this topic that they're referring to that we've been having a conversation about. So like I mentioned in the first video, large language models themselves don't have a memory. You literally just pass in prompt and then you get a conditional response based on the prompt that you pass in. In the past, people have tried to build transformer models with some kind of memory hooked into them, but nothing to date has been really optimal for this, enough that people want to start using it at scale. So this hopefully will come in the future, is that we have some kind of built-in memory to the transformer model, and then large language models will be able to retain things internally. At the moment, we have two main options for dealing with memory in a large language model. We either, one, put it back into the prompt, and the second way of doing this would be to have some kind of external lookup. And this one we'll look at briefly in this video, but in some of the future videos, I'm going to look at a lot at using databases and using things for externally looking up information and then bringing that back into the prompt. So the first version of doing this is basically where we just put the memory straight back into the prompt. So if we go back to our prompt that we talked about earlier on, we've got a context. So the context in this case is you're a digital assistant who enjoys having conversations called Kate. And then you can see here, we then just basically tell it, right, the current conversation that's gone on already, and this would be sort of user, one, saying, hi, I am Sam. The agent then says, hi, Sam, how are you? I say, I'm good. What's your name? The agent replies with, my name is Kate. And then the user saying, how are you today, Kate? So you can see all of this information would go into the prompt. And this sort of raises some of the problems with having memory in these things, is that while this is a good way to do it and it allows the language model to track what's going on in the conversation, if we keep talking for an hour, there's no way that that's going to fit into the span of tokens that the language model can take. The latest models from OpenAI are using around 4,096 tokens for the span. While that is good, that's a great amount of information, that's not going to hold a full conversation. So then this raises a whole bunch of issues of what are some of the ways that we can do this. So LangChain has a whole bunch of these built in. Some of them doing just very simple things like what I showed you just before, where we're just putting it into the prompt normally. Then we've got other ones that do things like summarize the conversation as it goes along. We've got other ones where we limit the window, so it only remembers the last few encounters. And then we've got sort of things where, it merges some of those. So where it has the last few, but then it does a summary for everything else. The summary, though, is actually done by calling out to a language model itself and asking it, hey, summarize this conversation. So that's something that you will see as well. Then we've got some sort of more external ways of doing this. So these can be things like making some kind of knowledge graph memory. and putting things into sort of entity memory for doing these kinds of things. And then lastly, you can just customize it, right? So you can come up, if you've got a very unique case that you want to use the memory or something yourself, you can actually write your own system for doing memory with this in LangChain as well. Let's jump into the code and look at how these things work. Okay, so we've got the normal sort of setup of installing OpenAI, LangChain, etc. Put your OpenAI key in there. And the first one we're going to look at is basically the conversation buffer memory. So in LangChain, we need to import the type of memory it is, and then we will basically instantiate that, and then we'll pass it into the chain. So the chain that we're using here is just a simple conversation chain, which allows us to basically converse with the model by doing conversation predict and then passing in what we want to say. And you'll see that as we go through this, that I've got it set to verbose equals true so that we can see what the prompt is going in, and we can then see the response that we're getting back. So here we're basically setting up the simplest kind of memory, the conversation buffer, and it's just going to basically track what the user says, what the agent says, and then just stack that into the prompt as we go through. So you can see we start off with me saying, "Hi there, I'm Sam." And we can see that the prompt that's going in, this prompt here, and we can see the current conversation basically is just human, "Hi there, I am Sam." And then the AI is going to respond, "Hi Sam, my name is AI. It's nice to meet you. What brings you here today?" All right. So then we're going to respond to that. So in this case, I'm going to ask it actually, "How are you today?" So I asked that. So I didn't directly even answer it. Let's see how it handles it. It's got no problem with that. "I'm doing great. Thanks for asking. How about you?" Then again, "I'm good, thank you. Can you help me with some customer support?" So you notice that now we come into this one and it's stacking our conversation. So this is the prompt that is going into the large language model. And all this is doing is just making this prompt longer each turn. And I have asked it, "Okay, can you help me with customer support?" It says, "Absolutely. What kind of customer support do you need?" And then I could keep going with this conversation, but this is going to get longer and longer. So at any point, we can sort of look at the conversation memory buffer and we can see, okay, what actually was said. So this allows us to, if we want to save out the conversation, we want to look at the conversation at any point, we can just come in here and do this. So you can see here is the conversation, exactly what we had up there above. So that's the simplest form of memory in LangChain. It's still very powerful, especially if you've got something where you know that people are going to have a limited number of interactions with your bot, or you're actually going to sort of hard code that after 5 interactions, it shuts down, something like that, then this kind of memory will work really well. The next kind of memory is conversation summary memory. So here we're basically, again, importing this in, we're instantiating the summary memory, and we're going to put it in here. So the difference now is rather than passing everything that I say and the bot says back and forth into the actual prompt, it's now going to actually do a summary of that. So you can see at the start, we will get something like this. "Okay, hi there, I'm Sam," right? It's response, "Hi Sam, my name is AI. It's nice to meet you. What brings you here today?" I say, "How are you today?" Same as before. But you notice now on this second interaction, so this is the second thing I've said. So I've got first one up there, second one I've said now, and now it's not showing what I said the first time, it's summarizing that. So you can see the human introduces themselves as Sam and the AI introduces itself as AI. The AI then asks what brings Sam here today. So this is different. Now, in this case, we've actually used more tokens, right, at this stage. But you'll see that as we go through, if I can say, "Okay, can you help me with some customer support?" Now, when we go to the next summary, the human introduces themselves as Sam, the AI introduces as AI, then finally it gets to the AI is doing great, and then it will give the last thing. So this is sort of at the start, maybe is actually adding more tokens because you're getting a sort of summarized version of the whole conversation. But over time, this is definitely going to be used less tokens. So you'll see that here now it's answering. And then if I went on with this conversation, I would then be able to see that, okay, it's not actually storing what we say verbatim. It's storing a summary of the conversation as a whole. So here, if we come down and look at conversation.memory.buffer, we can see our summary. And our summary is basically of the whole thing. So each time that it does a new summary, so we've got multiple calls to a large language model here. We've got the call for the response, but we've also got a call for actually summarizing the conversation. So after the first step doesn't need a summary, but after the first step, you've got a summary of the conversation at each point. And we can basically just print that out. And we can look at it and we can see that the AI response is doing great. When Sam asks for customer support, the AI responds positively and asks what kind of customer support Sam needs. So you'll notice here that it's kind of doing a co-reference resolution in that rather than a human would probably say it responds to what he asked or she, here it's sticking to AI and Sam in there. So this is a summary one. It's also very useful. The next one is kind of an alternate version of the first one that we had. So this is a conversation buffer window memory. So we're going to be doing the same sort of thing of just feeding the conversation into the prompt. But the difference is now we're going to set the last number of interactions that we are setting in here. Now I've set this very low just so we could see it here. But you could actually set this to be much higher than this. You could get like the last 5 or 10 interactions, depending on how many tokens you want to use. And this also comes down to also how much money you want to spend for this kind of thing. So we're instantiating it, setting k equals 2 here. We've got a conversation. Hi there, I'm Sam. What brings you here today? I'm looking for some customer support. So it's asking me what kind of customer support do you need? My TV's not working. So now we've got our 2 things going. So now it's going to ask me again, sorry to hear for that. It's asking for more information. I give it the information. But you notice now when I tell it, I turn it on, make some weird noises, and then goes black. And the prompt now has the last interactions, right? The last 2 full interactions that we've had, plus this new one. But it's lost that first one where I said, hi, I'm Sam. So it's just feeding the last 2 interactions into the large language model. So if you've got something where, like, let's say we set it to k equals 5, most conversations probably aren't going to change hugely. It will sometimes refer back to things early on in the conversation. But a lot of times you can sort of fool people with just a very short memory, with a memory of just 3 to 5 steps back in the conversation. You can see if we look at the conversation memory buffer, though, it's still got the full conversation in there. So if we wanted to use that to look at it or store it or something. The next one is kind of a combination of the first ones in that now we're going to have a summary like the second one we looked at, but we're also going to have a buffer in there as well. So here we're basically setting it to have a buffer of the number of tokens, where we're going to have basically the tokens is going to be limited to 40 tokens. So we could set it, a few different ways for that, but we've instantiated this memory like that. And then we're going to go through it again. So just quickly, hi there, I'm Sam. Nothing really different going on here. We've got I need help with my broken TV. And you can see it's just taking in steps of the conversation at this point. It asks me why. I basically tell it what's wrong. And suddenly now in this interaction, we've now gone beyond where we were. So now it's doing a summary of the early steps. So the human, Sam, introduces themselves to the AI. The AI responds and asks what brings Sam to them today. And then it gives us the actual conversation for the last k number of steps, or the last number of tokens in this case. So you can see here that, okay, I've answered that. It doesn't sound good. Do you know if it's a hardware issue? I say it seems to be a hardware issue. And sure enough, now the summary is updated as well, right? So we've lost one step in the conversation, but we've updated the summary to include that, right? The AI expresses sympathy and asks what the problem is in there. So this is kind of like giving you a little bit of the best of both worlds in there. At any point too, we can actually sort of print out the sort of moving summary buffer. So if we want to see like, okay, what's the summary at this point of the conversation? So this could be useful for a variety of different things. If you want to have some other module extract information from the conversation or something like that, you can try passing this into that as it goes through. The next two are a little bit different. So the next two, it's trying to basically represent the conversation and extract information from the conversation based on what's said in the form of sort of entities and a knowledge graph memory. So this one is the knowledge graph memory. So conversation KG is for knowledge graph. Rest of it's the same. We've got a simple sort of prompt in there. And I've just put the prompt in there just so you can sort of see, what it's actually doing is that it's added to the prompt now with the AI only uses information contained in relevant information section and does not hallucinate. So the idea here is we're trying to get it more to just focus on what we said and not add to that in any way. We instantiate it just like normal. We've got our conversation again there. Hi, I'm Sam. Starts off like normal. But you'll see that anytime that it thinks that there's relevant information, it will pass that in. So if I go through and basically say, right, this is what's wrong with it, and I give it, some information, it's actually taking that information and constructing a sort of little mini knowledge graph for that. So it actually, you should be able to sort of plot this out, but just showing you this rather than plotting it out is that we see that we've got this sort of little network X graph that's been made. So we can see that Sam, okay, the first two are nodes, and the third one is always what's connecting them. So, okay, Sam is human. TV is broken, true. TV weird sounds makes. TV black goes black. TV is under warranty, yes, right? Device is under warranty, and this is the warranty number that we've got here. So you can see it's extracted some really useful information for that. And this could be really useful for things like if you wanted to fire some other prompt or do something different, once you know that it's about a TV, this would be able to extract that out easily and pass that information to your bot, which can then respond in different ways, or could then, break off into different chains, etc. Entity memory. So this is doing a similar kind of thing, just in now that it's looking for specific kind of entities. Yeah, and we could even put some examples of that into the prompt if we wanted to do this. So have a read of the prompt. The prompt's kind of interesting how that's done. But then basically you've got the same sort of conversation chain. We're passing in the prompt. We're passing in the instantiated conversational memory here. We've got our same conversation. I've abbreviated a little bit here. Hi, I'm Sam. My TV is broken, but it's under warranty. Right. So now we can see that it's found some entities there. That's like, oh, okay, it's got Sam, it's got TV. Right. And then it responds to that. Hi, I'm sorry to hear that your TV is breaking. Is there anything I can do to help? How can I get it fixed? The warranty number is, and then I give it that. So you can see it's extracted that out from this, and it's got that in case it wants to use it going forward. And sure enough, it does use that, right? We can see that, okay, it looks like your TV is still under warranty. To get it fixed, you'll need to contact the manufacturer and provide them with the warranty number, and it gives me the warranty number back, which it's got in its context now. So if we look at the entity memory from the last step, we can see that, okay, we've got that warranty. That's what it got from the last step that's in its cache. Let's go on with this. Can you send the repair person called Dave to fix it? And we can see that it's worked out that, okay, yeah, there's an entity there of Dave. It says, sure, I can send Dave to fix your TV. Can you provide me with his contact information? So it's not kind of clued in that it's supposed to be the TV repair place. But anyway, finally, so we've done quite a number of steps now. Finally, we can look at the last entity that came out was Dave, but we can also just print out the entire memory store here that's got all the entities that it's got. And you can see, sure enough, that it's got this, and then it's got, okay, this is the warranty number for Sam's TV. And notice that I never said that, right? It's rephrased what I've said to do that. It's got Dave. Dave is a repair person. It's got Sam. Sam owns a TV that is currently broken and under warranty. And then we've got TV. The TV is under warranty. So entity memory can be really useful for extracting things out. If people are talking about relationships or something like that, this can be really good. If someone starts telling a story to the bot and they're telling, oh, and my sister is called this and her son is this, this is one of the ways you could use to extract that kind of thing. So I haven't got an example of the custom memory one here. If people are interested, let me know in the comments and I'll build one to show you. But you can sort of combine different memories as well on top of this. Perhaps we'll look at that maybe later on. But this gives you a sense of like what the memories are and how they get used in these bots for building your own conversational agent. All right. If this was helpful to you, please give it a like and subscribe. I've got more videos of LangChain coming. Talk to you soon.